Okay, so how might you surveil people indirectly? I mean, this is pretty clear. Yeah, you're trying to rip holes in the way to communicate. What about indirectly violating people's privacy? Well, there are lots of companies now, very big companies, that like to use big data to enhance their business model. Make use of these massive data sets that they collect. And the private companies. Facebook is an interesting example. They have some facial recognition capabilities. So they actually tried running this a few years ago. They got photos of George Clooney and said, okay, let's find George Clooney in all the Facebook photos. So they uploaded some photos of him, different angles, to recognize him, and they went, boom, scanned all Facebook photos. And you got this little sort of timeline of George Clooney in the background of all these photos around the world. Because George Clooney doesn't have a Facebook account, that you all do. So when you sit in the background, you know, sipping his coffee or buying a sandwich or walking to the airport, and you're like, you know, taking some selfie in front of the Eiffel Tower, George Clooney's in the background. You might not be able to see his face, but the facial recognition algorithms in Facebook can. And so they do complete trace. Suppose you're George Clooney. Only math would start a sentence in, assume you're George Clooney. How do you feel about this? Are you happy that your entire life is now being tracked? Basically from when you leave your house to when you get back in. And if this annoys you, who do you hold accountable? Facebook for storing the data? The developers for creating the systems and platform by which to store this data? The public for taking selfies in front of monuments and landmarks? The computer scientists for writing the facial recognition software? Who do you hold accountable? Here we're designing tools for other purposes. You know, Facebook, you take a photo, your birthday, and it says, hey, you want to tag Frank in your photo? You want to tag Susan in your photo? Okay, great. The facial recognition algorithm is helping me. But anything that helps you can also harm you. So maybe this is a convenient thing, locally, but when viewed more globally, it can actually cause a problem. Who do you hold accountable? And think about that. We'll talk about this in the discussion session. If this does bother you, who should you shake a finger at and say, no, stop doing that? Hint, good luck shaking a finger at 2 billion Facebook users for posting pictures of themselves doing stupid shit. That's never going to work. So try again. Companies like Google, Dropbox, Facebook store large amounts of your data. Google and Dropbox have very large amounts of your data. I'm sure you've got large files and stuff up there. But it's fairly poorly parsed. It's in big blobs. Your email account, big blob. Not that easy for machines to read. Companies like Facebook store less data, but it's more accurate. You've said, this is my cousin, this is the shop I went to, this is my birthday, this is where I work. Everything's passed by you. It's nicely filtered so machines can read it. Facebook creates this platform. You enable people to give way more information than they should really be giving about themselves. This is what I mean by indirectly violating people's privacy. Giving people the opportunity to kick themselves in the nuts is what you're doing. And they do it. That's what people like to do. Little convenient, fun thing. Look, fun photos, yay, Facebook. Tinder holds even less data about you. Tiny fraction compared to Facebook, which is probably a tiny fraction compared to Google and Dropbox. But I'm even more worried about what data Tinder holds about me. Why might I be worried about that? What data is Tinder holding about me? Rough geographic location, and all the people I'm trying to sleep with. Just that. Not much. Don't tell my wife that.
These are math words, I don't think you should think about that.
So, it's not just how much data someone has on you, it's the type of data. If you create a system like this where people happily sit there swiping yes, no, no, yes, no, yes, no, and Tinder's recording all this, very small amounts of data, that can come back to bite you later on. Because at the moment you think, well, you know, I'm just an undergraduate. Who cares if I like people of a certain size or colour or gender or whatever? I'm just you know, a second-year maths student. So you can do whatever stupid. What happens in 20 years' time if you have some sort of political career, if you have some sort of position of power? Now Tinder has something over you. So you of today, plus Tinder's great little interface and their little developers, is screwing over you of 20 years' time. And that might be used against you. Just think about it. If every swipe that you do now came back printed on a billboard in 20 years' time. Who's still happy and thinks Tinder's great and fun and awesome? Yeah. Indirectly violating privacy. Hey look, we're making a way for people to match up. Yeah, but what else is happening? Be careful how you construct these platforms and systems. Think ahead. Make a button for an opt-in, not an opt-out. Because many of you will go to these big tech companies and do work. Here's a great example of making a button that was opt-out rather than opt-in. So a company called Strava, and they worked with companies like Fitbit, allowed you to upload all your Fitbit data. And you can see when you go for a jog and whatever, and little heat maps. So you've got a little map of the world, and here's you, so here's some map, and here's your house. That's got a little picture of you go in the morning and you go to the local park, and then you run around the park 10 times, and then you go back home. So these are all sort of data sets. So someone in Strava decided, hey, wouldn't it be cool if we got everyone's data set, deleted their name, and then put it up on the internet? What a great idea. Go team. So what happens? So you go, yay, little Johnny goes to a little morning jog, and little Sarah goes to the shop and buys milk and comes home, or whatever, great, or goes to work. Someone else goes to bicycle. Oh, and then you've got the middle of the Afghan desert, where there's goat farmers and people running in perfect squares. And maybe like a little sort of path here and a path there and a path. So something like this in the middle of the Afghan desert. Now the value of Fitbit is about twice what an Afghan goat farmer earns in a year. So why are there so many Afghan goat farmers running in perfect squares in the middle of the Afghan desert? Guess what? They're not Afghan goat farmers. These are secret US military installations. These were a secret US military installation. They're not anymore. To the point where you can see the actual road structure of the installation. In fact, there's a great one. So you look at Google, Area 51. It's this dated in blob. Google Maps says, nah, you can't look at Area 51, it's top secret. But Strava doesn't know that. There's some guy likes to go on a bicycle ride in the middle of Area 51. There's a little path telling you exactly where the road is in Area 51. Well done. Well done. Who's to blame? Blame the soldiers? Blame the army for not seeing it? Blame Fitbit? Blame Strava? Blame whoever's running this, developing these apps? If you create an ultra-convenient system and don't put any sort of checks on it, and Strava's response was, well, they should have just opted out. No, they don't know to do that. They've got the little app and they're running and look how many steps I did. You ever seen that? People actually counting how many steps while they're walking around these things? Mind-numbing. How is your average soldier supposed to realize that this is such a security vulnerability? No, they're freaking soldiers. Come on a bike over in the morning, for Christ's sake. He's in the middle of the Afghan desert. He's doing his thing. But this information is useful to some people. Possibly some nefarious people. We are the ones developing this stuff. And even if you anonymize it, hey, I took the names off. Well, it's not the name. I don't care that this guy's named Frank. I care that he's running in a perfect square in the Afghan desert. I couldn't care less what this person's name is. But I care that this path goes right to the middle of Area 51. And I now have a roadmap image of Area 51. I never thought I'd see this in my life. This is incredible. Be careful how you build these things. Be aware that you're building these things. Give me a second. I spoke to someone who worked at Facebook at the careers fair last year, so 364 days ago. And he told me about the thing, he was an algebraic geometer. The guy just finished algebraic geometry PhD, I think at MIT or Stanford. And he was working on Facebook, and I said to him, you did algebraic geometry, what do you do? I mean, how do you connect these two? He goes, oh, we're working on a great project that's called Facebook Click and Track. I'm like, oh shit, here we go. Please tell me more about this great program. Oh, so the user is on Facebook and they click on an ad. Yeah? And so we tell the advertiser they click on the ad. I'm like, okay, I believe that. Keep going. He says, okay, so then when you click on the ad, if the advertiser's paid a premium, then we physically track the user's location until they go into the shop owned by the advertiser, and then we tell the advertiser when they went in and how long they spent in there. Like, you do that? Yeah, we do. It's really great. It's cool. It's awesome. It's like a tiny Facebook. No, those T-shirts they wear in Facebook always 2 sizes too small. I don't get that. So he's happy. He's standing there. Look at me. I'm young and I'm doing math and it's great. I said, is this some like super secret project that you've just told me about? No. It's been rolled out for a little while now. It's working really well. Well, define working and define well, but okay. And I said, okay, is this like, do people use this? Yeah, lots of advertisers use it. You know, you click on the shoe shop ad on Wednesday, and then on Friday you go to the shop at 4 o'clock, and we track that you went in. Because everyone has Facebook on their phone, and they have GPS enabled. Apparently there's some subtleties. You have to sort of like actually, because GPS is not that accurate, you've got to sort of try and figure out, you know, using demographics and stuff, okay, was this actually this person? Is this the shop they went into? So there is some technical work behind there. It's not just as simple as one line of code. Hence the algebraic geometry. All those sorts of skills. I said, okay, I mean, I don't use Facebook, so maybe you can tell me, when the user clicks on this ad, do you tell them that they're now going to be physically tracked through the world until they visit the shop? He said, oh, we don't do that. Why not? Well, it's all in terms and conditions. Like, no, listen up, Einstein. No one reads that shit. But more importantly, even if they could read that shit, that's 600 pages worth of stuff. And inside there are things like, you know, we can record your clicks 5 pages later. We can get your GPS location 5 pages later. We can give data to advertisers 5 pages later. Not everyone has a PhD in algebraic geometry, thank God. So even though it's obvious to you, with your 15 years of deep mathematical education, it might not be obvious to everybody else. So you build a platform like this, people are being exploited. This is what I mean by indirect privacy violation. You're not trying to violate people's privacy, you're trying to tell the advertiser that, hey, so-and-so bought some shoes 2 days after clicking your ad. But in the process, you're moving around way more data than the user's probably comfortable with. I said to him, why don't you put the little pop-up saying, we're now going to track your physical location. He did the blood drain from his face. And I said, okay, well, what sort of conversations have you had at work about this? He said, well, we haven't had any. We never thought to speak about it. Like, there lies your problem. You've never spoken about this. You never thought, well, what are the implications? Just, hey, look, I'm doing geometry. This is indirect violation of privacy. We're mathematicians. We try to make the world better and more efficient. Math doesn't have any intrinsic notion of good or bad. Just like nuclear weapons don't have any intrinsic notion of good or bad. But if you do something with them, that could do good things and do bad things. And that's what you have to remember. It can be used for, these little convenience tools can be used for good, but also for bad. Each time we make life more convenient for others, we have to think carefully about the drawbacks. And one example I like to use here is big data is reminding me more and more of asbestos. In the 1950s, asbestos seemed like a freaking great idea. It was awesome, it was fireproof, it was cheap, it was strong, it didn't corrode. Great, let's put asbestos in everything. Then a little bit later, people realized, oh, hang on, this is actually really, really, really bad for us. Like, freaking bad for us. It gives us cancer. Oh, and by the way, getting rid of it? almost impossible. You ever seen a house where they're trying to remove asbestos? They basically build an extra house around it, twice the size, and then people go in spacesuits trying to remove the asbestos. That's exactly the same as what's going to happen with big data. This stuff's really convenient, really cheap, really awesome, solves a couple of problems, everyone's happy using it. In 20 years' time, it's going to give us all cancer of some form, figuratively speaking, and getting rid of it is going to be practically impossible. Prohibitively expensive. You can get rid of asbestos from the house, and it costs about the same as demolishing the house and rebuilding it. We have to be careful with what we're building here indirectly. We're not trying to screw things up, just like people making asbestos, we're trying to screw things up, but, oops. The last thing I'll point out, and it's an easy one, is we violate people's privacy out of stupidity. We design things, and we don't do it properly. Do we go all out to make our data systems safe? Do we know that when you store someone's password, you have to hash the password? Even more, you have to salt and then hash the password. You don't just store people's passwords in plain text on your system. Well, some people do, and this is called being stupid. Please. Anyone else got these? I mean, this happens all the time. I once received an email from my undergraduate institution, University of Melbourne, and it was to all mathematics alumni that they had an email for. And someone had put it in the to list rather than the CC list. This email was 7 megabytes of email addresses. The actual message was, we have a new fundraising thing, please click here to participate. So I now have a complete list of all the math alumni from my department from the mid-1990s until 2016, 17, I think it was It's really, that person wasn't a mathematician. It's really easy to be stupid, but being a little bit stupid just once can really screw people over. Now if I want to do recruitment for whatever companies in Australia, I have a giant cache of mathematicians I can send to, for example. It's our responsibility to respect and protect the privacy of people who provide data to us. Be careful with what you collect. If you don't need it, delete it. And if you create a system whereby you can collect the data, but you're not confident enough in yourself to keep it private, to keep it secure, then you're being irresponsible by collecting it. Collecting it and saying, oops, some 16-year-old backyard hacker just hacked my system, that doesn't fly. That's not good enough. We've seen countless examples of this. Last 5 years, Sony, Ashley Madison, Yahoo, TalkTalk, Adobe, all these massive data breaches. My credit card was reissued last month. The bank just said, we're going to give you a credit card. Like, why? Oh, there was a data breach. Apparently, Ticketmaster had a massive data breach. I didn't know about this actually. And the bank realized it was cheaper to reissue all the credit cards that had used Ticketmaster in the last 4 years, 5 years, whatever it was, than to pay out what they knew would be the fraud claims. Be careful about the data you collect. Protecting data is hard. What's the best way to protect a piece of data? The absolute best way to protect it. Don't have it. And if you have had it, delete it. Smash it. Right, fire. You forgot some way to back up. So don't have it in the first place. If you do delete it, make sure you check where all the copies went. Don't ask people stuff you don't need. If you're an online flower shop, why do you need someone's date of birth? No, really, why do you need someone's date of birth? Stop asking them. I mean, you want it because you want to collect this data and then sell it to some advertiser or something, sure. Yeah, but I'm the one buying the flowers. I don't send flowers to myself. Have you heard what they mean?
I think that you can now send the flowers to the person who you sent the flowers to, saying, it's such and such birthday.
So when these things go wrong, who's to blame? It's difficult. Don't set up these positions where something can go wrong. That's what I mean by stupidity. Just being careless, not being careful enough. People are trusting you with your data, but don't realise how important that is until they get screwed by it. So, in summary, the only thing more dangerous than having no cryptography, no privacy, is having false cryptography, false privacy. Because if you know you're being surveilled, you self-censor. That's just stupid shit. If you think you're saying stuff safely, then you're much more open in what you say. The Germans learned this lesson the hard way in World War II. They transmitted everything because they thought England was perfectly safe. It didn't work so well for them. Mary, Queen of Scots, thought that she had a great way to communicate with her collaborator in London about overthrowing the monarch. Turns out her encryption wasn't so safe. And then her head parted company with her shoulders. These things can come back to bite you if you think that you have cryptography when you don't. If you know you're being surveilled, you self-censor. Lulling people into false sense of security is the greatest possible violation of privacy. You're baiting them into screwing themselves over. And that's where this stuff sort of comes in. Indirectly, stupidly, and even directly. Don't put effort into constructing systems that are going to violate people's privacy by breaking their encryption tools. Because if you can do it, someone else can steal it from you and do it as well. You can't own this. It's math. You don't own math. Just because you put your name on a theorem doesn't mean you own it. You don't ever own mathematical output. Anyone can use it. So I leave with this question. Imagine a world where there is no privacy whatsoever. Everyone knows everything about everyone. Sorry, but some people know everything about everyone. This is the world that mathematicians are creating. Whether you agree or disagree with this notion of privacy, I don't know. But you better think about it, because that's what we're working towards. That's what we're contributing to. That's what we're building. Your work might seem abstract when you're doing it, but its impact is not.